All right, howdy, howdy. So, video now, this one's gonna be, we finished kind of the top part of 19 where we did light as a particle. But in this video, we're gonna do light as a wave and finish up the bottom half. So this page of the notes should already look something like this. As a review, light is kind of like a cylinder in that depending on how you look at it, the shadow might be more like a square. It might be more like a circle. So light sometimes behaves as a particle. Sometimes it behaves as a wave. Sometimes it seems like it's matter. Sometimes it's energy. Confusing, but that's the way it is. So Einstein's experiment did the particle stuff. Lots of other people's experiments showed that light kind of has some wave properties to it. But there's one guy in particular that we're going to study his experiment. So the name of the experiment, it's called the double slit experiment. And it was by a person called Thomas Young. Double slit experiment. Before we talk about that, let me just talk about an experiment with like a single slit. So ignoring the little picture here, if we had a wall, color in the wall, it's a wall over here, and you can't get through on any of the sides because it's a wall, but I'm not going to draw the whole thing. So there we go, can't get through. There is one slit. Interestingly enough, when light is shined through a slit, it does this thing where it kind of like it goes outward, like outward. And that's what's going on here in this picture. Just keep in mind that mine has one slit and his box experiment had two slits. We still have a light source entering, hitting the slits. We just have two of them. So the light going in from one kind of radiates out, bloop, 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 bloop. And it doesn't matter what color marker you want to choose. But from slit one, when the light enters here, it's like bloop, bloop, bloop. And I'm going to do all of these in green. Why green? Because I just grabbed a marker. No significance to green. The other one, ooh, pink. Cool. The light entering from this hole does the same thing. It radiates out, bloop, bloop, and it makes like this kind of cool pattern. When two waves collide, there's a couple of different things that can happen. We'll come back to this. Let me show you some cool stuff that I have in some videos. So what I've got here is it's a bunch of popsicle sticks, and I've spaced them out and I hot glued them onto two pieces of string. Okay, pretty simple. Took me about an hour. So here, be careful, I don't mess this up. Okay. So here's my little machine, and what this does is it simulates a wave. If I hit it, like, let's see, here, you see how it like, whoop, it flows through. I can whack it on one side and the wave propagates down. I can't really do this very well because I'm alone in my classroom here, but usually I'll hold it out like this. I'll have a student whack it from one side. I'll have a student whack it from the other side. And when they meet in the middle, we watch the types of interactions that they can have, right? Because either when the students hit them, they're both gonna be coming up together and hitting, or maybe one's down and the other is up. So let me record that or find a video so you can see the two types of collisions on those waves. Okay, resume recording. I found a video. So let's do a screen share. Yep, let's do this video big. So here we go. So he hits both sides and we've got two up waves coming into each other. Whoa! And they collide. Let's watch that again. That was cool. Here they come. And look, they get twice as big. Wave one, wave two, and then they construct this like really big one in the middle. They combine. This is called constructive interference because you've got two waves that are like, they're both up waves. It could happen with two down waves. As long as they're going the same way, they're gonna make a wave that's like the sum of both of them together. If you have an up wave coming in with a down wave, when they collide, it's just gonna be flat and nothing. Okay, let's see. Now this one, what this one is we've got, instead of one wave, we got two waves, kind of like two, like, I don't know, just like two in the water's blue. So we've got two spouts and they're both moving up and down. And this is cool. Like, do you see what's happening with the bands? Like we get little stripy patterns. We've got one that's going this way, like, oop, there's a stripe, there's a stripe, there's a stripe. I'll let it play and continue. And it's up, down, and they just and some of them are colliding together. Whoa, does that look familiar? Some of them are colliding together and making a big up wave, and some of them are colliding one up, one down to deconstruct. So these little spirals here are showing exactly what we drew in the notebook, right? Light as it whoop, 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 whoop. No, go back.
On average, college graduates have
On
a
average,
$40,000
college
debt.
graduates, that's depressing. Okay, let me have a pharmacy ad here. Anyway, skip ad, yes, please. When you have waves coming together, one of the characteristics of waves is that they combine or they cancel, and it makes those stripe patterns, which we're looking at here in the notebook. Okay, so in this video here that I'm going to share with you, this is backwards. This is a recreation of the double slit experiment. He's got a box, he's carrying it, and he goes around and he starts asking people, what is light? And I'll turn the sound on, hopefully you'll be able to hear it. But he asks people, what is light? And they give like the craziest answers. So let me start it back over.
What is light?
What is light? What is light? That's a good question, isn't it? What is light?
Isn't it an element?
Light is brightness, I guess.
We have auras,
We all have auras.
which are light.
Yes, they are.
It lights up the room. It makes it not dark.
What's the difference between blue light and red light?
The color.
It goes in your eyes and then you see stuff.
They range from
I feel like I'm watching like one of those React videos.
White to red to orange to green. It's like the chakras of your body.
Can you see my aura?
No, not particularly right now.
Is it too bright out?
It's very sunny out here today.
Does that make it harder to see someone's aura?
Not necessarily.
If I was to explain it to a blind
Oh, this
person,
guy's my favorite.
right?
Yeah.
It would be the difference. You see nothing whatsoever as a blind person, whereas I see things in front of me.
To be fair, the question of what light is
Pretty terrible description. Okay, so he goes through and he basically explains the same thing that I was getting at, where we've got this pond and he's making waves in the pond. And he shows how when you do double, he's got tennis balls and he's waving them into the water. Let me turn off subtitles so we can see better. He starts to dip them in at the same time and makes waves. And just like in the simulation, you can actually see here are the wave patterns. Look, there's a line, whoop, there's a line, bloop, 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 bloop. Very entertaining. That's a great shot. There's your money shot. A poor duck would be like up, down, up, down, up, down. But a ducky here would be like, wee, 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 not really moving that much. Just chilling. A poor duck in here in the middle would be like up, down, up, down. So there's the idea. Now, Thomas Young did this with light. He had a box with two slits, and that's what all these people are sticking their faces into, this box with two slits, and they're saying what they see. What they end up seeing, let's find that spot here in the video, is this. So see how it's got stripes? Stripe, 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 up and down. Those stripes there are basically proving that the light from one side, one slit's light is coming in where the other one is as well. And just like when two water waves collide, there's those stripe patterns. This is saying, hey, light's not water, but it's still a wave because it's making a stripe pattern. So that's really, really cool, right? So back to the notes. Stop share. Yes, please stop sharing. Switch camera. So back to the notes here. It's like wave one, wave two, light comes in and blub, 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 blub. We're going to get intersection. We're going to get, is that the right word? Intersection? I'm going to say collisions kind of between like here, 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 here. Oh, nope, there's no collision there. My bad. Here, here, here. Collision, 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 collision. Let me make sure not to mess up again. And you can see like they come whoop, whoop, in these straight lines. Stripe, 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 stripe. And what it looks like is this. You've got white, black, white, black, white, black, just like what they were seeing inside of that box. So Thomas Young's double slit experiment basically showed that light is a wave because when waves come together, they have a distinct collision pattern. So let's see. I'm putting collide in quotes because it's not really a collision. It's just they come together. When waves come together, they follow distinct patterns of interference. They interfere with one another. Usually we can see the interference in the striping patterns. Or in the stripes. AKA stripe pattern equals waves. And since we got a stripe pattern when we had two light sources coming in, it was like light equals wave. Since light showed stripe interference, it can behave as a again, it's the idea that if you've got like one up wave coming in hot and another up wave coming in hot, they're going to combine into a really big one. Or if you've got, let's see, an up wave colliding with the down wave, when those meet in the middle, it's just going to be like a big nothing. When you go between nothing and really, really big, nothing big, nothing big, nothing big, nothing big, nothing big, nothing big, that's your stripes. So that's the rest of the notes for light as a wave.